In question 19, we begin looking at inequalities. In 19a, we have a linear inequality to solve. We're given 3 brackets 2x plus 1 is greater than 5 minus 2x. We're asked to find the set of values of x for which this is true. Starting off by expanding the brackets, and then gathering terms on one side. If I add 2x to both sides, I get this. And if I subtract 3 from both sides, I get this. Dividing both sides by 2, 2 divided by 8 gives me a quarter, and therefore I know that x is greater than a quarter. In part B, we have a quadratic inequality. It is stated as 2x squared minus 7x plus 3 is greater than 0. The first thing to do is to factorise this. 2 times 3 is 6, and I can achieve 6 with minus 1 times by minus 6, and that also sums to give me 7. So, making the split, and then factorising. Here I need to extract a common factor of minus 3. It's important to note this is being multiplied. Once we've factorised it, a sketch is helpful. Since this has a positive coefficient to the x squared term, this is the general shape. We can see that there are 2 solutions, so it must cross the x-axis, and also we do have a y-intercept, although its value isn't relevant to this question. The x-intercepts, however, are x is 3 and x is a half. 3 minus 3 is 0, 2 halves minus 1 is 0. Now we're looking at greater than 0, so we're looking above the x-axis. The corresponding parts of the x-axis that are above are here and here, and therefore we've got x is less than a half and x is greater than 3. We've not been asked to put these in set notation, but if we were, we could write it as and that would be in set notation. We've got the curly brackets, we've got a colon, and then we've got the inequality stated. And it's either going to be here or here. We're not suggesting that they both happen simultaneously, so we're using the or. In part C, we have to answer the question, find the set of values which satisfies both of these 2 inequalities. And for this, I'm going to use a number line. Here's our quadratic inequality from part B. And now I'd like to put on the linear inequality from part A. It's worth noting that the length of this arrow isn't of great significance. It's implied that it carries on forever. So, there's a region here where they overlap. And if we continue that arrow like I mentioned, there's a region from here onwards to infinity where they also overlap. This can be stated as and this and there we have our inequalities defining the possible sets of values of x. To do this in set notation, it would look like this. That's question 19.